In this section we're going to look at polynomial functions. Now that sounds very grandiose, but that's just a function that is of a particular format. Now we'll have a look at a few of them here before we have a look and work out the general form of what a polynomial equation looks like. So here's a polynomial equation here, and that's what it looks like. Now there's another one, and there's a third one. So we could keep going on and producing these polynomial equations, but what we want to do is we want to have a look and see the general format of a polynomial equation. So let's go ahead and we'll do that now. So if we open up this folder here, we've got the general format of a polynomial equation written here. So this is a polynomial equation. Now don't get worried about this, it's actually quite straightforward, and we'll work through and we'll see exactly what it looks like. Now if this is just a function, so the function just relates to the y quantities, so the y-axis, with the values on the x-axis. So this polynomial equation says that y is equal to some number, we'll call it a0, plus another number a1 times x, plus another number a2 x squared, then a3 x cubed, a4 x to the 4, a5 x to the 5, and it would continue on forever. So we would get a6 x to the 6, a7 x to the 7, and so on and so forth. Now I've only written down these first 1, 2, 3, 4, 5 terms just to get an indication of what these functions are going to look like. Now whenever we work with these through the rest of the course, we'll probably only work up to the value of a4 x to the 4. Now it's quite reasonable for you to say, but why bother with this particular format of function, and whereabouts did it come from, and why are we bothering with it in the first place? Well, they're all reasonable questions. Now it turns out that a function of this form is very, very useful in mathematics. Now we don't want to get into all of the details of whereabouts we're going to be using it, but we will go over in the last section of the course when we look at some more advanced mathematics, and we'll go through and we'll see why polynomials are so useful. So let's go ahead and we'll graph this polynomial. So what I've done is I've taken out the values of a0, a1, a2, a3, a4 and a5, and we can just adjust those values. Now I've set them all at 0 at the moment, so there's nothing on the graph. Now the thing to remember here about this equation is that we don't know what these values of a0, a1, a2, a3, a4 and a5, we get to choose those. Okay, so we choose those values. The value of x in x squared, x cubed, x to the 4, x to the 5, well, those are known quantities. I mean, x is just this axis. Now we actually call the axis in mathematics, we call it the independent variable. But we don't need to bother too much about that at the moment. All we're interested in is the fact that this is the x-axis. So we've got the x-axis, and in the x-axis squared, the x-axis cubed, 4 and to the power of 5. So this is a fixed thing, okay? So that's just every number, every real number from minus infinity to plus infinity that runs on that axis. So let's go ahead and we'll start putting in values for these. So we'll start off at a0. So if I put in a value for a0, well, that's just simply the line, and you can see that line appearing. So I'll move this back a bit so we can see more of it. So that's just the equation of a line. So for example, we get to this point at 5, and that's just the equation of the line is y equals 5. So for every x coordinate, the y coordinate is just a value of 5. So that's the line y equals 5. So you can see the straight line is a polynomial. Now if we were to put that back to 0, and we'll take the second one, so here's the second one there, and that looks familiar. So that's just the equation of a line that goes through the origin. So that's our, if you like, when we did our equation of the line, we had y equals mx, and that's all you've really got here. You've got a value of x, and the number before it, that would be the gradient. So that a1 is just like the gradient m whenever we looked at the equation y equals mx. So this line here is also a polynomial. So now if we adjust the value of a0, we can move this line up and down. So that's just the general equation of a straight line. So all we really have here for the first two terms is like saying y equals, and this would be mx plus c. But the m is actually a1 and the c is we called a0. So the general equation of a straight line, or a straight line, is just a polynomial. Now let's go see what happens when we add in the next term. So that's the a2x squared. You see it curving up, and we can get it to curve down. Okay, so let's go ahead and we'll add in the next term. So it's the a3. Okay, and we'll also add in this term, this previous term here. So it's the a2 and the a3. So you can see this shape occurring. And then we can try the a4. Whoa. So what you can do is open this up and just have a mess about with the values of the constants. So these constants are called the coefficients. So there you can see all the different shapes that you can create. So in general, what we could say is that if you were to say, just take your pencil and draw some kind of random curve, say like this, across a screen, then that curve would be a polynomial. Or we could approximate the curve using a polynomial function. So that's us had a look at what polynomial functions are and what they look like. What we want to be able to do is manipulate polynomial functions in the same way we're able to manipulate the equations of straight lines and also circles and all of the other functions that we've come up across so far. So let's go ahead and we'll have a look at that.